In this lesson here, we're going to be taking a look at the surface area of composite shapes. Now, the term composite is what we would normally use as like mixing things together. Okay, if you think of like a composite hockey stick or a composite alloy or something along those lines, it's usually two different things or two or more different things mixed together to make some sort of better product or a gauntlet of products, so to speak. A composite shape, or I'm going to use the term composite object. I need to change my notes on this one, but I'm going to use a composite object. Okay, so a composite object, a shape I usually use as 2D, object I'll use as 3D, is an object which is made up of two or more regular 3D shapes. Okay, so it's made up of two or more regular 3D shapes. Now that could be in a couple different ways, and we're going to look at a couple different ways that we make it up. But it's going to be two or more different regular 3D shapes that we looked at, whether they're prisms, cones, pyramids, or spheres or hemispheres. Again, these can be any shapes, and they can be placed together in any way. So they can be placed together in really any way. To find the surface area of a composite shape, okay, we need to find the area, of any composite object, in this case again, object, only the parts of the object that are visible need to be included. Okay, I'm going to say this a little bit tongue-in-cheek here. Okay, only the parts that are visible need to be included. It means that if you can hold the object in your hand, what could you all see? If you could flip it around and if you could manipulate it in any way, what could all be seen? Some objects are placed on the ground and maybe you'd have to be able to walk around or fly above. Okay, maybe that bottom doesn't have to be seen. But if you can grab an object and place it in your hand, like I have this ball, I can turn it around and I can see all the sides of the ball. Okay, that I have to find all of the sides, not just skip some of them. But I'm only going to include the ones that are visible in that idea or as that idea. So let's take a look at the first one here. Okay, the first shape that we're going to look at is this composite shape right here. Now, to find the surface area of that, okay, we need to first determine the shapes. Actually, no, sorry, I will use objects. There we go. Objects which are in this composite object. Okay, which regular 3D objects do we see in this composite object? Well, if we take a look at it, we have two different objects right here. The first one right here is this one on top, and the second one is the one underneath. Okay. And you can probably tell fairly straightforward and fairly clearly that this one up here is a cylinder. Okay. So we have a cylinder on top, and on the bottom, this here is a rectangular prism. Right, prism, there we go. That is a rectangular prism. So we have a cylinder on top and a rectangular prism on the bottom. Now what we're going to do here is we're going to find the surface area of each of those 3D objects. So we're going to find the surface area of the cylinder and we're going to find the surface area of the rectangular prism. Okay, so let's start off, let's do that. I'm just going to work my way down here a little bit. And I'm going to start by finding the surface area of, let's do the cylinder first. Okay, cylinder, surface area formula. Surface area is equal to 2 pi r squared plus 2 pi r h. There we go. Okay, there's our formula. Let's get all of our values in there. 2 times pi times the radius, slip up it, 4 feet is the radius, squared, plus 2 times pi, times the radius again, 4 feet, times the height of the cylinder, and you'll notice that's the 8 feet right up here. There's our height, 8 feet. And if we do the calculations, I'm going to use my calculator. This is going to take a little bit here. 2 times pi times 4 squared plus 2 times pi times 4 times 8. And that gives 301.59 feet squared. And let's get surface area equals in front there. All right, there is the cylinder. Okay, so we found the cylinder in this case here. We have that it's 301.59 square feet of space. Okay, there we go. We got that part done first. Now let's do the rectangular prism. I'm going to change the color with which I'm using. And so the rectangular prism, this one, the formula is surface area is equal to 2 times length times width plus 2 times length times height plus 2 times height times width. There we go. Okay, there's our formula for it. We have 14 feet, 8 feet, and 12 feet as our three. I'll quickly label this. This one I'm going to call let's call this the length. Let's call this the width. And we'll call this the height. Now with a rectangular prism, it really doesn't matter what we call each one of these. It's more so, it's a matter of recognizing that each one of them is one of our measurements, and we have 3 measurements, and that's all we need, okay? So there's measurements we'll use. And so then surface area is equal to 2 times, I said length first, right? 14 feet times width, which is 8 feet, plus 2 times length, 14 feet, times height, 12 feet, plus 2 times height, 12 feet, times width, 8 feet. There we go. Now we're going to find what is the surface area of this whole piece. Again, I'm going to use my calculator, and we're going to do 2 times 14 times 8 plus 2 times 14 times 12 plus 2 times 12 times 8. And I get 752 feet squared. All right, so what we've now done here is we have found the area of the full cylinder and the area of the rectangular prism, and that is kind of a big part of our composite object right here. The next step going forward here is that we need to subtract the areas which are not seen. We need to subtract the areas which are not seen. And this includes areas that are covered, which are covered by other objects. So if we take a look at this composite object here, I'm just going to use a pen for a second here. This cylinder sits on top of the rectangular prism. Right inside there, okay, the bottom of the cylinder and that piece on top of the rectangular prism are not seen. They are in fact actually glued together, so they are not considered surface area. Okay, they're glued together, so they're not considered to be surface area. Therefore, we actually need to get rid of those 2 sections. We need to subtract those 2 sections off. Okay? To do that, we first have to figure out what the area is of one of those. So I'm just going to go down here, and we need to figure out what the area is of one of those circles. Let's do this like here. Okay, the area of a circle is pi r squared. Therefore, we said, so the circle that we're looking at here is this one right up here. Okay, so this is the piece we got to take off. Okay, so it's got a radius of 4 feet. Area is equal to pi times 4 feet squared. And that means that the area is pi times 4 squared. Okay, try to get that on there. There we go. Pi times 4 squared. And that's equal to 50.27 square feet. Okay, that's the area that we need to subtract from both of these. We have to subtract from the bottom of the cylinder because we can't see the bottom of the cylinder. We also need to subtract it from the top of this rectangular prism because that part is covered. So we have to subtract it twice. One area we need to subtract twice. So what I will do actually is I'm going to take this and I'm going to go into here and I am going to times this by 2. So it's 100.54 feet squared. So that is the area of the circles, and this needs to be subtracted. Okay, and I'm going to put circles in there instead of just circle. Okay, that's the area that needs to be subtracted. 2 circles needs to be subtracted. Now I'm going to put this right here at the bottom because I'm kind of running out of space and I want to keep everything neat and tidy here in order. So the total surface area let's try this again here. Total surface area is going to be the 301.59 that we found for our cylinder, plus we're going to add the 752 square feet that we found for our rectangular prism, minus the 100.54 square feet that we are not going to need because of the parts that are combined. Okay, so parts that are combined we do not need to include, so those ones we are going to put off there. Now, I think I have just enough room here right at the bottom. So surface area is equal to, let's do the calculations, 301.59 plus 752 minus 100.54, and this gives us a total of 953.05 feet squared. At 953.05 feet squared, and that is because we have subtracted the parts that we do not need. So, in summary, and let's just go through this one more time here, we start by finding the surface area of each of our pieces. Okay, determine the objects that we have, we find the surface area of each. Next, we determine the area that is not needed or that needs to be subtracted off. Now, this could be a little bit different depending on the type of object we have, and I'll show you an example of that in just a little bit. Okay? But we subtract the area that we don't need. Finally, we add the areas of the objects together. So we add the area of the objects together, and that's going to give us our entire surface area. Now, I put a little note in here. I said to prevent confusion, please label all your work related to each area of the shape. So you'll notice here that I labeled, this is my cylinder part, this is my rectangular prism part, these are my circles, okay? This is the total surface area. I'm showing my work and I'm making sure to label it directly so that I can see what's going on, so that you know what's going on. We want to make sure that everybody understands what you are trying to solve or what you are trying to find in there. So that is finding the surface area when we're adding 2 shapes together and then subtracting the part that is unseen.